All right, when solving quadratic functions using the square root method, we just got done going through this video, there will be some other formats that you see that are a little bit more extensive, I guess you could say, than the straight x squared equals 9, that type of equation you saw in number 1. So, if I was going to do number 1 down here, the other forms you'll see part, again, the first thing I always look for is there a b term, or is there a linear x term? Linear x term, b. And in this case, no, there's an a term, and these look like c terms, right? Because it's just there's just a constant number that exists there. There's no b term. So this tells me that I can go ahead and use the square root method. And so, or at least try it, because the square root method is a lot easier than the quadratic formula at times as well. There's less work involved. So this is, I would look, and I've noticed there's no b term, so I'm done with that. And then the first step again is to isolate quadratic term. You took these notes in the previous video, but it's always good to reiterate them. So, isolate the quadratic term. The quadratic term is paired with this 4x here. The first thing I have to do is move the furthest thing away from it. This 4 is closer than this 6, so I have to move that 6 over to the other side of the equation. That 6 is being added to it, so I need to subtract it to get rid of it. Whatever I do to one side, I have to do to the other side. So the plus and minus cancel out the 6's on this side, so I'm left with 4x squared equals 206 minus 6 is 200. Now, the next mental check should be, is my quadratic term by itself? It is not yet. It's still paired with that 4. That 4 is being multiplied to the x squared, so that means in order to get rid of multiplication, I have to divide by 4 to cancel it out. Whatever I do to one side, I have to do to the other. So, division would cancel out that 4 on that side. I'm left with x squared equals 200 divided by 4 is 50. Now, the second step is to take the square root. So I'll write that out. Take square root. To cancel out radical. I'm sorry, to cancel out the power. The quadratic power right here. So, if I take the square root on this side to cancel that out, I have to do it on the other side too. That cancels it out, so I'm left with x equals plus or minus the square root of 50, right? Now, we have to consider, when I take the square root, is 50 a perfect square? You should hopefully know that it's not, but if you don't, you can always check it on your calculator. It comes out to a really long decimal, 7 point something. So in that case, I'm going to move it up here so I have some more room. X equals plus or minus, I have to break this down into simplest radical terms. So, factor tree. And again, remember when we're looking for factor trees, we're looking for pairs eventually. 50 ends in 0, so I know that 10 goes into it. 50 divided by 10 is 5. So 10 and 5 are partners. No pairs yet. Break down 10 into 5 and 2. 10 divided by 5 is 2. 5 can be broken down into 5 and 1, but there's no really point in doing that. I can do that again if necessary. But the only pairs that I see are the 5's. So what's left inside is technically the 2 times the 1, which is just 2. So my final answer, I will write in green down here, is x equals plus or minus. Remember, if pairs of numbers come out, they come out as just the number itself. So 5 times the radical. What's left inside is 2 times 1, which is just 2. So this is my final answer. The positive and negative version of 5 root 2. And I'm done. Let's move on to number 2. This one looks a little bit different. In this case, the quadratic term is also paired with a 3. Now, when I say this looks a little different, but it says to isolate the quadratic term. So in this case, this step right here, this entire thing is considered to be my quadratic term now because those parentheses make it included, so it has to include the 3. So in this case, my first step, it is technically already isolated because there's nothing else with this quadratic term. These are stuck inside that power, and so it is by itself. So I can move on to step 2, taking the square root to cancel it out. So I'll square root this and square root this. That will free up what's inside the power on the left side because the radical cancels out the power. So I'm left with x plus 3 on the left side. I can remove these parentheses after they become free of the power. And x plus 3 equals plus and minus 3. Now it's just a simple linear equation. The term x, the variable, is still paired with this 3. So the 3 is being added, so I'd have to subtract it from that side and then subtract it from this side. Now, the one thing about this process now, if you notice, there's a positive version and a negative version of this 3 on this side. So I have to do 2 steps here, 2 sets of little math steps. I have to use the positive version 3 and subtract, I'll switch to green here, subtract 3 from it, and that equals x, the positive version minus 3. 3 minus 3 is 0. So one answer is 0. And then I have to do the negative version right here, the negative version of this 3. So I do negative 3 minus 3. And in that case, negative 3 minus 3 is a negative 6. So my 2 solutions, my final answer that I need to see are 0, negative 6. If you remember, whenever solving quadratic functions, you should always get 2 answers. I got 2 answers over here, plus and minus 5 root 2, and I got 2 answers over here, 0 and negative 6. The reason it worked out to where, and I should mental check this as well as you're doing this, the reason it worked out to where I had to do this step here is because it was a perfect square to begin with, right here. And a perfect square breaks down to a whole number. There will be times when you do problems like number 2 where it won't break, or it won't be a perfect square, so it won't break down into a whole number. So then this step would look a little bit differently. But we will encounter that, or you will encounter that on your homework. And then as you work through that problem, we will talk about it if necessary at that point. Let's move on to number 3, the final problem that I want to talk about in this video. So number 3, again, the first step, first I would look again, is there a linear b term, the x term? And no, there isn't. All I see is the quadratic and the b that's paired with that quadratic. It's in parentheses with that 2 as well, but technically that's still the quadratic term. So that means that I can go ahead and try the square root method. Now again, with the square root method, my first step is to isolate the quadratic term, which in this case is stuck inside those parentheses with the 2. First step in doing that, I can't work with this 2 yet because it's trapped in there, and I have to move this 4. The furthest thing away from the quadratic term is the 4. That 4 is being added to it, so I've subtracted on both sides. And it's really nice if you line up your work like I'm doing, just so it can help you visualize what you're doing. So in this case then, the positive and negative 4 on the left side cancel each other out, so I'm left with b plus 2 still trapped in the parentheses, and that equals negative 12 minus 4 is a negative 16. So far so good. Now I have isolated the radical. I know it looks a little different because it's in a parenthesis, but I've isolated the power, but the power still exists there. And so now, then there's nothing else with it. So now I can take the square root of both sides to cancel out the power on the left side and free up what's underneath the power, the b plus 2. So on the left side now I have b plus 2, and that equals the positive and negative version of, remember, what's the square root of 16? Something should jump out at you. It's a negative 16. But again, I can treat it initially as just the square root of 16 equals plus or minus 4. So I know that it's going to be plus or minus 4. But in order to free up that negative to come up out of the radical, remember, you need to tell me that you've entered into the realm of imaginary numbers by using the letter I. Because there's no real number that would multiply with itself to get back to negative 16. So you have to use I here. So far so good. Now I have one last step to free and isolate my variable. This 2 is being added to it, so I have to subtract it, and I have to subtract it from this side as well. So in this case, I have b equals, so in the same thing, I have to do what I did up here for this step, and this is kind of what you would encounter if the radical didn't break down to a whole number. I have to do the positive version of 4i, the positive version of 4i, and I have to subtract 2 from it, and I have to do the negative version of 4i and subtract 2 from it. Because technically here I'm subtracting 2 from 2 different numbers, the positive and negative version of both. And questions arise at this point down here of, can I do this math? Can I combine these things? And technically I can't. They're 2 different numbers. This is what's called a complex conjugate, meaning that this number, the 4i, is a complex number, and this number, the negative 2, is just a regular real number. So they can't be combined. So you have to leave your answer just like this. A positive 4i minus 2 and a negative 4i minus 2. I know it looks different, but these are numbers, this 4i minus 2 and the negative 4i minus 2, and they can't be combined. So if you ever encounter a situation where you do all this math and you're left with something like the square root of, or 2 times the square root of 5, and you have to subtract 2 from it, same thing. You can't combine this negative 2 with this number. This number is an irrational number. This is a real number, so they can't be combined. So you have to leave it as 2 root 5 minus 2. So, number 3, this is the final answer. And those are, for the most part, the situations that you will encounter when you attack solving quadratic functions using the square root method.